All right, so let's start. Quiz 13. Okay, quiz 13. Question 4. Nick, can you read first?
Find the solution exactly on the interval 0, 2 pi. Sine 2 sine theta equals negative 2 square root of 2.
Very good. All right, so let's consider this one. So since from this equation, we have this one. So divide by 2 on both sides. We got sine theta is negative square root 2 over 2. Now, over the interval from 0 to 2 pi, based on the unit circle, we know that theta is what? Either 5 pi over 4 or 7 pi over 4, right? So this is question 4, 3 points. Now let's consider question 26. All right, question 26. Salim, can you read first?
Sorry. Find all solution exactly on the interval 0 to pi. 2 tan square root 2 t equal 3 second t.
Okay, very good. All right. Okay. Here is a solution since as we know the alternative forms, right? So tangent theta, tangent t square equals secant t square minus 1. Yes. Okay. So this is the alternative forms of the Pythagorean identity. 1 plus tangent square t equals secant square t. Yes, it's one of the alternative one. But then, of course, the tangent square t is going to be secant square minus 1. Okay, and then we will have 2 tangent square equals 2 secant t square minus 1, which equals this. Yes. Now, therefore, we will have for this equation, it will be what? 2 tangent equals this one equals 3 secant t, which means what? We got a quadratic equation about secant t, right? About secant t. Now, using the quadratic formula, we found secant t equals, all right, plug in everything, it equals this one. That is what secant t equals 2, or secant t equals negative 1/2. Right? Okay. So, well, however, secant t, as we know, secant t equals 1 over cosine t. Now, this one cannot be less than 1 or in between negative 1 to 1 because it's 1 over cosine, right? 1 over cosine must be what? Cosine is between negative 1 and 1. So 1 over cosine will be greater than 1 or greater or equal than 1 or less or equal than negative 1. So this one is out of range. We drop it, right? Because the range of secant t, right, is 1 through infinity or negative infinity to negative 1. So we cannot have that. All right. So therefore we have, we only can take this one, right? So cosine t equals 1 over secant t is 1/2. Now over the interval 0 to 2 pi, we know that t is pi over 3 or 5 pi over 3. Now some of us using plus minus plus 2k pi. You don't need this one, right? You don't need this 2k pi because we are given specified on this interval from 0 to 2 pi, right? So you just give the value over that interval. That'll be fine. Now let's consider question 34. Natalie, can you read first, please?
Solve with the methods shown in this section exactly on interval 0 to 2 pi. Sine 6, cosine 11x minus cosine 6x sine 11x equals negative 0.1.
Very good. All right, very good. Let's consider this one, right? So apparently, well, as we can see on the left-hand side, it is sine, cosine, minus cosine, sine, right? Okay, so it's the difference between two products. All right, the first product is sine cosine, the second is cosine sine. So, and the angles, right? So 6x, 6x, 11x, 11x. So we're going to use the formula, the sum and difference formula for sines, right? So as we know, sine of alpha minus beta, right? Alpha minus beta for this one is a difference, right? So equals what? Sine alpha cosine beta minus cosine alpha sine of beta. Yeah, this is the formula we use, right? So therefore, this one, when alpha is 6x, beta is 11x. So we have the left-hand side is simply the sine of 6x minus 11x, which is sine of negative 5x, which is negative sine 5x, because the sine is odd function. All right, so that is to say the left-hand side is simply negative sine 5x. Therefore, we know this one equals -1, which is equivalent to this one. A negative sine 5x equals negative 0.1, and sine 5x is 0.1, right? Sine x is 0.1. So since sine 5x is 0.1, all right, so we would have, okay, so for sine of 5x equals 0.1, right? So 5x is going to be sine inverse 0.1. So this is the solution on the interval from negative pi over 2 to pi over 2. Yes, it belongs to this one. Actually, this one is going to be greater than 0, less than pi over 2. Yes. Okay, so you can calculate this value. It is actually belongs to the first quadrant. It is in the first quadrant. Okay. Now another value within the first radius for first period is going to be what? Is a pi minus, right? The sine inverse of 0.1. In the second quadrant, the sign is also positive, right? Okay, so it is also possible that 5x equals this one value. Okay, so that's why we have what? 5x can be, well, then you can plus minus 2k pi and plus 2k pi here, right? So any coterminal angles will be good, all right, will be also good. So we will have these two equations, either 5x equals sine inverse sine 0.1 plus 2k pi, or 5x equal to pi minus this one plus 2k pi. Okay, so these two are fine. All right, this is from sine 5x equals 0.1. So the complete solution is going to be this one, right? 5x equals that, or 5x equals this. Okay, so then we can just divide by 5 on both sides. All right, so you can find that from the first equation we found divided by 5. So x equal to sine inverse sine 0.1 divided by 5 plus 2k pi over 5. Yes. Okay, this is the first set of solutions. Or the second is x equal divided by 5. This is a negative divided by 5. Here is pi plus 2k pi. So that's 2k plus 1 pi. Divided by 5, that's divided by 5. So that's what we have here. Okay, so therefore,
I have a question.
Go ahead.
So you said that it gives us like the range, like 0 to 2 pi in the question.
Yep.
Right.
Mm-hmm.
Can we still do the plus 2k pi, or?
Yeah. Well,
Why
the range. The range is about x, right? So you're solving for x in the range. Correct. It's like what we did here for t is in the range of 0 to 2 pi. Yes.
Range is the y, right? Y. Range is the y.
Well, the range is the set of the possible values of a function. All right. So the interval is about the domain. All right. This on the interval 0 to 2 pi means what? for all those x values on the interval 0 to 2 pi such that this equation holds. Does that make sense?
Okay. Yeah.
So you want to solve the equation on the interval, means you want to find all the values of x here
like
in this one.
26 said the same thing, but you didn't write plus 2k pi. That's my question. Like, why do you put it plus 2k pi for the 36?
For this question instead of the this, like this one, I didn't write anything.
26.
Yes.
Yeah.
So
Yeah.
26 because it's a lot easier, right? 26 is as cosine t, right? So cosine t is 1/2. Correct?
Okay.
So for cosine t equals 1/2, it is very easy to identify the values of t on the interval 0 to 2 pi such that the cosine t is 1/2. Yes?
Okay.
This is pretty easy to identify, yes? So
Yeah.
we can immediately tell that is pi over 3 or 5 pi over 3 because of the unit circle, right?
Yeah.
Now similarly is for 4, right? It's pretty easy because sine theta is negative square root 2 over 2, so we can easily tell that on this interval, theta can be 5 pi over 4 or 7 pi over 4. Now, the question, the story is different for this question, 3, 4. So we're not having what? Sine of x is 0.1. Instead, we have sine 5x. Yes? 5x is 0.1. It's not like sine x. If sine x is 0.1, then, well, there are just two answers, right? So if it is sine x is 0.1, then this we do not have to write in this way and identify all those values, right? But this one is a little different because we have a complicated situation, right? So because the sine 5x is 0.1, now you need to count all those values of x such that sine 5x is 0.1, right? Such that sine 5x is 0.1. So you would need, all right, well, it's better to do this way, all right? It's such that you can identify those values of x on this interval, and from 0 to 2 pi, right? So you cannot say find x is less than 0 or greater than 2 pi. That's not good, right? So you got to firstly list the general solution here. All right, I got the general solution. And then I will consider what values of pi, or for what values of k, right? For what values of k, such that the x values, this root, right, will be between what? 0 to 2 pi. Does that make sense? Now I'm going to say it's not all k works, right? So as you know, we need to find a solution on this interval from 0 to 2 pi. So you cannot say, okay, any k works, right? So you got to choose the k values such that the x value is between 0 and 2 pi. Now, what are they? Well, in k is 0. All right. So x1 is this one, x2 equals this. So basically, I'm going to apply for this one when k is 0, and k is 0 for this, x1, x2. Right? When k is 0, I know that this one is sine inverse sine 0.1 over 5. x2 is going to be negative over 5. Does that make sense? All right. So well, how about k equals -1? Is -1 works? Why I started with k equals 0 instead of k equals -1?
K -1 would take you outside the range, wouldn't it?
Yep. That's the reason why, right? If k equals -1, then the x value, for instance, 1 is going to be what? Sine inverse 0.1 over 5 minus, right? Plus negative 2 pi over 5. This is apparently less than 0. Correct?
Mhm.
So, of course, k cannot be negative 1. So the least possible value for k is k is equal to 0. And for k equal to 0, we have x1, x2 equals x1 equals this, x2 equals this. And then we just add 1 each time, all right? Until what? Until we got a value that is going to be greater than 2 pi, right? So the k equal to 0, k equals 1, and you compare it, it's good. It's still way between 0 and 2 pi because that's over 5, right? Over 5. So k equal to 2, good. K equal to 3, still good. K equal to 4, still good. Now, can k equal to 5? You cannot have k equal to 5. All right, if k equals 5, my x will be what? Sine inverse 0.1 over 5 plus k equals to 5, that's 10 pi over 5, right? So that is 2 pi plus a positive value, right? That's going to be out of the range, correct?
Okay.
So I cannot have k equal to 5.
Okay.
Now that's why I'm just taking k equal to from 0 to 4. And I have these 10 possible values on this interval from 0 to 2 pi, such that this equation holds.
Okay.
Right? So this is why we are doing this, all right? Because it's easier this way. Firstly, find a general solution, and then you check each k for which it is the solution is on the interval 0 to 2 pi. Okay, I have k equal to 0, k equal to 1, k equal to 2, k equal to 3, and k equals 4, right? K equals 4. That's the only possible values, and you got everything. All right. So that is for question 34. All right, question 34. Okay. Nick, you have a question, right?
Yeah, I was looking at some of the exercise program projects. Can you look at 37? I think it is.
37. Okay.
Yes, please.
37. Let's do that. Okay, 37. Oh, okay, this one, right?
Yeah.
Okay, so let's do this one together. All right. So, well, this is a question that is similar to actually, it is similar to an example we did in class. If you remember that, all right. If you remember, so we are having, okay, there's a quadratic equation here. It's similar to, okay. Well, it might be similar to this one. Okay, similar. Okay, but let me just show you why it is similar. Okay, so, well, not this one, but the one we had is not this one. Yeah, it's like this one, double angle formula. Okay, using the double angle formula. It's similar to this example. Okay, but let's go with this one. All right, so this one is 9 cosine 2 theta equals to 9 cosine squared minus 4, right? So what you want to do is you want to change it into a quadratic interval, right? Quadratic equation involving, say, well, this is already involving cosine, so you may want to change it to a quadratic equation involving cosine, right? Involving cosine. But how can we do that? You use the double angle formula, right? Cosine 2 theta equals what? Involving cosine, so it equals what?
2 cosine
Square theta minus 1. Right? So use this one. Then it's gonna be, you plug in there and that's going to be a quadratic equation about cosine, right? So this one will be what, 9 times that. That's going to be 18 cosine square theta minus 9 equals 9 cosine square theta minus 4, right? So it's going to be 9 cosine square theta equals 9 minus 4, which is 5. All right, you can solve for cosine, right?
Mhm.
Okay, everything else will be easy. This is, you can solve for cosine. Cosine can be positive or negative, or well, within this one, right? So you can solve for cosine and then the possible values of theta. Okay, very good. All right. Unfortunately, I thought I posted that it probably is not successful on the Blackboard. Okay, but I will post both homework questions for section 9.5 and also today's class. All right. So probably more extra work today, right? Okay. So now let's move on to our lectures. Okay, so in this new chapter 4, we're going to introduce some applications of trigonometry, and equations. All right, so section 1 is about the law of sines. Anybody heard about law of sines? No? Okay, some of you heard about it. Okay, the law of sines is a very interesting law or fact about triangle. Okay, so before we introduce the law of sines, we introduce this so-called oblique triangle. Okay, so what is an oblique triangle? Now it is any triangle that is not a right triangle, right? So any triangle that is not a right triangle. So as long as there's no right angle in the triangle, then it is an oblique triangle. Now we have this definition, oblique triangle. Now solving an oblique triangle means, all right, what do we mean by solving an oblique triangle? Means what? Find all 3 angles and all 3 sides. All right, all 3 angles, all 3 sides. Say this is alpha, this is beta, this is gamma, and this is A, and this is B, and this is C. Okay, so these sides are A, B, and C, right? The angles are alpha, beta, and gamma. So to solving an oblique triangle means what? Find all the sides and all the angles. Yes? Okay, that's what we mean. All right, you got to find all the angles. What is alpha? What is beta? What is gamma? All right, alpha, beta, gamma. Now here alpha, beta, and this is gamma. These are Greek letters. All right, these are Greek letters. Now we usually use what? Greek letters for angles, right? We can use Greek letters to represent angles. And this A, B, C are the sides, the lengths of the sides, the measurements of the sides. Okay. Now, of course, we would need some information to solve these angles, to solve an oblique triangle. All right. We need to start with at least 3 of these values. At least 3. Okay, including at least 1 of the sides. Okay, if you just give 3 angles, for instance, if you just give 3 angles, then you know this one you can shrink it, right? Or expand it. You do not know the side, the length of the sides, right? So they can be similar to each other, but you do not know the size, right? So you need to know at least 3 of these values, including at least 1 of the sides, right? 1 of the sides must be included. So we would have what? ASA angle, side, angle, right? So for instance, we know the value for C, we know the value for B, and we also know the angle between C and B, right? So that's ASA. Oh,
Do they have to be
sorry,
like-
sorry. This angle, side, angle. Sorry. This is sorry. This is C. This is C. This should be alpha, gamma, B, right? So alpha angle, B is the size, gamma is another angle, right? So angle, side, angle, or AAS means angle, side, right? You know alpha, you know gamma, and also you know A, right? Angle, side, or side, angle, all right? You cycle like this is BA or gamma or something. Well, we will introduce each case, all right? We will introduce each case, all right? So anyway, so we would need to start with at least 3 of these values, including at least one of the sides, okay? And then we can solve this oblique triangle, okay? So that means what? We want to find the values for alpha, beta, gamma, and also the values of A, B, and C, okay? Now let's consider the law of sines, all right, law of sines. Let's consider this figure here. All right, consider this figure here. Okay, so you have alpha, beta, and gamma, the size A, B, and C, right? A, B, and C. Now, let's say that the height is h. Height is given here as h, right? So use the right triangle relationship. We know that what? We know for this alpha here, right, this angle, sine of alpha is what? Is h over b, right? It is h over b. Okay, so we know that the sine alpha is the opposite over the hypotenuse. So sine alpha is h over b. Now similarly, you also have what? For beta. For beta, right? Sine of beta is h over a. Yes? Okay? Sine of beta is h over a. Correct? So you will have what? From this from this equation, I will have h equals b times the sine of alpha. I multiply b on both sides. I got h equal to b times sine alpha. Yes? And similarly, from this one, I know h equals a times the sine of beta. Right? Now I got, based on 2 different right triangles, I got this equation for the height and this equation again for the height. So we will have what? H equal to b sine alpha equals a sine beta. Does that make sense? Okay, so therefore we will have, right, if we divide, okay, if you divide a times b, okay, so b sine alpha over ab equals a sine beta over AB. I divide AB on both sides, right? So it's going to be the same. Now you can see that B and B cancel out. Here A and A cancel out. So which implies what? Sine alpha over A equals sine of beta over B. Right? So you got this too. Sine alpha over A equals sine B beta over B. Now, similarly, you can also prove that sine of alpha over A equals sine gamma over C. All right, this one is also true. So based on these two, right? So then they seems like it to be the same, right? Sin alpha over A is this one, sin alpha over A equals sin gamma over C. So we will have that this proportion sine of alpha over sine over A equals sine gamma over B equals sine beta over B equals sine gamma over C. So that is what we have. This is the law of sines. These ratios are exactly the same. All right. So given a triangle with angles and opposite sides labeled below. All right. Be careful the labels. Okay. Alpha, beta, and gamma. Right. The opposite side of alpha is A. The opposite side of beta is B. The opposite side of gamma is C. Right? So sine of alpha over its opposite side. Right? Over its opposite side. Sine alpha over A, sine beta over B, sine gamma over C. These ratios are exactly the same. Right? Are exactly the same. Now, of course, since the ratios are the same, the reciprocals will be again the same. A over sine equals B over A over sine alpha, B over sine beta, and C over sine gamma will be also the same. Good. Okay. So that is what we have for law of sines. Yes. Okay. Now let's see how can we solve an oblique triangle using law of sines. All right, let's consider for different cases. Okay, so consider one. So this one, okay, say, Jared, can you read for us, please?
Solve the triangle shown in the figure to the nearest tenth.
Okay, very good. All right, consider this triangle, right? So what do we have? What do we have here? Okay, so here we are given two angles and one side, right? Two angles and one side. This is a 50 degree, this is 30 degree, and this value is 10, right? Two angles and one side, all right? Two angles and one side. So solving the, by solving this one, what do we mean? All right, we want to find out, now the angle beta is ungiven, so what is angle beta, right? So C is unknown, B is unknown. We want to find these values. Is that right? Okay, so that's what we want to find. Okay, now firstly, I think it's easy to find the value for beta, right? So how to find the value for beta?
You take 180 minus the combination of the other two angles.
Yes, because the total angle of a triangle is 180, right? So we know that the beta is going to be the 180 minus the summation of the other two. All right. So solution. Since alpha plus beta plus gamma should be always 180 degrees, it means what? The beta equals 180 degrees minus alpha minus beta equals 180 degrees minus 50 degree minus 30 degree. That is what? 100 degrees, right? 100 degrees. Now we have these ones, right? We already found this beta angle. All right, this is we already have this angle. All the angles are known now, right? All the angles are known now. And we still in short of two sides, B and C, right? We just need B and C, and we are done with this triangle, right? So we will know everything about this triangle, all the three angles and all the three sides. Okay, so how to find the B and C? So for this one, we can use, all right, the second equation. All right, either way will be fine, all right, but I think it's better to use the second one, all right. A over sine alpha, B over sine beta, C over sine gamma will be exactly the same, all right. So based on by the law of sines, we have what? All right, so A equals 10, right? A is 10. 10 is known, right? So you can say that 10 over sine 50 degrees equals B over what?
100. Sine of
100. Yeah, sine beta, that's sine 100. Which equals C over
Sine 30.
sine 30. Yes. 30 degrees. Okay. So now this equation can be written as 2, right? As 2 or 3, all right, or any way you want to write it. But now this guy we have everything, right? So the ratio can be found using the calculator. Yes. Okay, we can find this exact value. Now let's consider. So from this one, we can get some interesting facts. Firstly, consider, okay, this is the sine of 50 degrees. All right, this is, firstly, we have B. Now consider this equation, right? Consider, now firstly, 10 over sine 50 equals B over sine 100, right? If this is a condition, so what is the value of B? You multiply sine 100 on both sides, right? So that's going to be sine 100 degree times what?
10 over
10
sine 50.
over sine 50 degrees. Now, calculator, right? So calculator, all right. So what is going to be that? Sine 100 angle degree, close the parenthesis, times 10 over sine 50 second angle degrees. What did you get?
$12.8557 or
558. Yes, very good. All right, 12 point. But we need only this in this equation is the nearest tens, right? So this one is already given the specific rounding accuracy, right? So we just round to the nearest tens. So what would be that?
12.9.
12.9. Yes. Okay, so we round to the nearest tens, 12.9. Okay, B is 12.9. So what about C? C, you consider what? That this one and this is the same, right? So C over sine 30 equals 10 over sine 50. Yes. Okay. So C will be what?
It will be sine 30 times 10 over sine 50.
10 over sine 50. Yes. Now again, you can find this value, right? So sine 30 actually is just 1/2. Yes. Sine 30 is just 1/2 times 10 over sine 50 degrees. Parentheses. What did you have?
6.53.
6. Well, round to the nearest tenths, right? Nearest
Yeah.
tenths. So that's
Yeah.
going to be 6.5. Yes,
Okay.
because it's the nearest tenths, right? So now we have everything, right? So we have solved this triangle for because we got the values for alpha is 50, beta is 30, beta is 100, gamma is 30, A is 10, B is 12.9, C is 6.5. So we have everything about this triangle. So that means we solved this triangle, right? Very good. Now then let's consider the second category is about given two sides and one angle. Given two sides and one angle. Now this one may have 4 different outcomes. Okay, may have 4 different outcomes. Consider the figure below. It illustrates the solutions with the known sides A, B, and the known angle alpha. Okay, so if this one is h, h is the height from this point to the side C. All right, h is C. Now, if A is less than C, less than h, like this one, right? If A is less than h, then this is not going to be a triangle. All right, this is not going to be a triangle. Okay, so this is the first case. It's just too short. All right, so it's just too short. Now, the second case is a right triangle. If A, the size A equals h. Okay, equals
H is the height, is the hypotenuse.
is h is the height. All right, h actually is what is let me just draw this one. All right, so because you're given this is b, right? B is given, and this angle alpha is given, and the length A is given. A is also given, right? I do not know the length of A. I know the length of A, but I would know if B and alpha is given, I will know this height. This height equals what? Height is going to be B times sine alpha, yes? Because sine of alpha equals h over b. Is that right? It's the opposite over the hypotenuse is b. Sine alpha is h over b. So h equals b times the sine alpha. If you multiply b on both sides, h is b times sine alpha. Yes? So that is to say, if your A, the opposite side, A, is smaller than h, right? It can never touch. If it is smaller than A, it can never touch this side. Yes? Because the shorter the distance from the end of side B here to the other side is h, right? So in this case, no triangle. Right? There's no such triangle because A is too short. Even shorter than h, which is b times sine alpha. Make sense? Okay. Now, a second case is the right triangle. The right triangle. So the right triangle is when A is exactly H. So in this case, it's just one triangle. Okay, when A is the right triangle, that's the case B. Okay, so when A equals H, it means A here is just a triangle, a right triangle. Now, the completed case is the third case. I may have two possible condition, possible ways. All right. So when A is greater than H, but A is less than B. In this case, it is possible that it is somewhere here or somewhere here. Okay. So this triangle may be it is this triangle, right? Maybe it's this triangle, right? So A is greater than C, greater than H, but less than B, right? Or it might be what? It might be this triangle. All right, as you can see from the figure, right? So there's two possible cases. All right, there are two possible cases when A is greater than H but less than B. Okay, so this is the two possible cases for C. Okay, now finally, if A is greater or equal than B, then it's just a one triangle. All right, if A is greater or equal than B, then just one triangle. Okay. All right. So that's what we have for this SSA for these oblique triangles, right? Oblique triangles. So we have this side-side angle, right? Side-side angle. Given this one, one is A is the opposite of alpha, B is the adjacent side of alpha. Then given this A, B, and alpha, then we will have these four different classes, A, B, C, and D, right? So in case A, no triangle. Case B is right triangle. Case C is two triangles. Case D is one triangle. Now, consider this one, right? Consider this one. Joshua, can you read for us, please?
Solve the triangle with the angle 35 degrees, the adjacent side of 8 and the opposite side of 6 to the nearest 10.
Very good. All right, very good. Let's consider this one. So we will have one triangle, 35. Let's say that this is 35. All right. The adjacent side is, say that this is alpha. Let's say that this is alpha 35 degrees, right? 35 degrees. Adjacent side is 8. So this is our B. Okay. Now let's say that, right? This is B. And the opposite side is 6. All right. So that might be what? So this is H. All right, so this might be A, this might be A, right? So it has two different possibilities. Now, how to determine that it has two possibilities? Here one is give you the hint, right? The hint is given here, but if there's no hint, what shall we do, right? What shall we do if there's no hint? So what we can do is, all right, firstly, find the value H. Yes. First, find the value H. As we know, H equals what? B times sin alpha. Yes. Now, adjacent side is 8, so B equals 8, right? So we know that its adjacent side is 8. So this angle is 35. So we know the H would be 8 times sine 35. Yes? Okay, so solution. Since H equals B sine of alpha equals what? Equals adjacent side, that's 8 times 35 sine of 35 degrees. And you can find this value using the calculator, right? So I believe that's 8 times sine 35 angle degrees. What do you have? I have 4.586. All right, I have this one. Now you see that which situation do we have? The opposite side is 6. Apparently, 6 is between what?
Between 8 and 4.5.
Yeah, and 6 is greater than H and less than 8, right? Less than the adjacent side. So we have two possibilities, right?
Mhm.
Two triangles. Now you may want to do this one, all right? So one, all right. So draw the case like this one. All right, I'm gonna do something like this. This is alpha, this is B, and this is A, this is beta, and this is a gamma, right? So in this case, all right, so this is the first case, all right, listed in below here. So what do we have? So we will have the law of the sines, right?
Mhm.
By the law of sines, we have, okay, so A is 6, right? 6 over sine alpha. Alpha is what? 35, right? 35 degrees. This one is going to equal to B. B is 8. Yes? Eight. Over sine beta. B over sine beta, right? Now, we would need a C as well, right? So here's C. So what is the value for C? We need to find the value for C, right? How can we find the value for C? In this case,
Could you use Pythagorean theorem?
Pythagorean theorem, right? So, but how?
6 squared and 8 squared equals c squared.
No, that's not a triangle, right? That's not a
Oh,
right triangle, right?
Yeah,
So you
that's
have to
why.
be
I see.
careful on that. So now here is some way you may consider this, but now sine beta can be easily found, right? This one is obviously known, right? So 6 over sine 35 degrees 8 is known, is B, right? B is 8 over sine beta. Now this one can be easily found, right? Sine beta can be found, correct? Now, it seems like we can find the sine beta first or beta first. Yes? Let's find the beta, right? And then we are going to find some others. Okay, so now this one is firstly find the beta, and if I find the beta, then the gamma can be found. Yes, right? Because the total is 180, right? So now this one means what? Okay, I'm not going to say this is one. All right, I'm going to solve them by once by this way. By law of science, we have this one. Now this means sine beta. Or I can do this. Instead of doing this, I want to using the the first one. All right, in sine on the top. All right, because that's easier for my calculation. All right, sine of alpha 35 degrees over 6 equals sine of beta over 8. B equals 8. Right, so this implies what? Sine of beta equals 8 times sine 35 degrees over 6. Yes, it's easier to use this one because it's easier for the calculation. All right, so 8 times sine 35 second angle degrees, close the parentheses, over 6. Okay, so what did you get?
I got 0.7647 or
48.
48. I'm sorry.
Yeah, 7648. Okay, now I can, since the sine beta equals this one, I can find the value for beta, right? So what are going to be the value for beta?
The inverse.
Yeah,
or no?
Inverse
Yeah.
sine. One of this is inverse sine 0.7648. Now this one is what? Less than 80 degrees, right? Less than 90 degrees. Yes.
Mm-hmm.
So let's find this degree. Round to 1 decimal place. Okay. So what do we have? Sine inverse 0.7648. What did you get?
0.8707.
7, but this is in what? In radians, right?
Mm-hmm.
In radians. Now this angle is in degrees for the first one, right? So we may want to convert it into degrees. Can you convert this one into degrees?
Yeah, it's
Convert what degrees?
Convert, well, this one equals, in the calculator, you got radians is 0.8707, but that's in radians, right?
So you just write the degrees sign on top of the 0.7648.
Yeah, so this one is convert to degrees, that's what? Anybody got this one? How to convert it to degrees?
Convert the 0.76 to degrees.
This one. 0.8707.
Is it just multiply by 180?
No. Okay. We can convert it by divided by pi times 180 using the equation. Okay. So well, if you do not want to do that, well, it's better to convert to degrees, all right? Because this one is using degrees, right? 35 degrees. So we may just convert them to degrees. So this one will be what? Will be the radian theta r is 0.8707, right? We want to find the theta. So we know that theta r over pi equals theta over 180. Remember that?
Mhm.
So theta equals what? Multiply 180 on both sides, right? Theta r over pi times 180 degrees. Does that make sense?
Mhm.
So basically what you do is what? Apply this formula divided by pi times 180 degree times 180. That will give you the degrees. So what is that?
49.88 or 49.89.
Okay, so but let's say it's round to nearest tenth, right? Nearest
Mhm.
tenth. So that's
Sure.
going to be 49.9 degrees. Mustafa, any questions?
I got it. Thank you.
Okay, good. All right, so we got beta is 49.9 degrees. Now, is this the only possible value for beta?
No,
No,
because
right?
because we have the other A.
Yeah, we have the other side. It might be what? Greater than 90 degrees, right? So it may be what? Sine pi minus that, right? So pi minus this one. Or beta equals what? 180 minus this one, right? So it's going to be this angle, okay? So or 180 minus 49.9 degrees equals what? $130.1. Yes?
Mhm.
130.1. Okay, so this is the two possible values of beta, right? Two possible values of beta. Now, let's consider the first situation. Okay, so case one. When beta equals 49.9 degrees. Okay, when beta equals this one, then what is going to be the angle for gamma? The gamma is going to be what?
180 minus
180,
35 plus.
yeah, minus 35 degrees minus 49.9 degrees. That is going to be
95.1.
95.1, yes. 95.1 degrees. Yes. Okay. So now can we find the side for C in this case?
Mhm.
So by the law of science, we have, okay, C over sine gamma equals either way, right? Either way. So you can use 6 over sine alpha, which is 35 degrees. All right, so this one is already, well, the gamma is what? 95.1 degrees, right? Sine gamma equals C over sine 95.1 degrees equal to 6 over sine 35 degree. So you don't have to write the other one, right? So because you're only trying to find C. So C equals what? Sine 95.1 degrees times 6 over sine 35 degrees. What is that? What did you get?
I got negative 10.5.
That's not right. It should be cosine. It should be positive, right? There's no
Mhm.
negative number.
Is it 10.4?
Yes. All right. Round to 10 decimal tenths, round to the tenth, right? It's going to be 10.4. Okay. C equals 10.4. Okay. So now we have everything, right? So what do we have for this one? Alpha is 35 degrees. Beta is 49.9 degrees. Gamma is is 95.1 degrees. A equals 6, B equals 8, C equals 10.4. Right, this is case 1. Yes, I got all the angles and all the sides. Make sense? Bless you. Right? So I got everything for the case 1 when beta is 49.9. Now I also have, similarly, I can have the second case when beta equals what? 130.1. Gamma this one equals
14.9.
14.9. Yes, exactly. 14.9 degrees, right? So by the law of science, we have C over sine 14.9 degrees equals 6 over sine 35 degrees. So in this case, C equals sine 14.9 degrees times 6 over sine 35 degrees equals 'Anybody found this one?
$2.6897 or
Yeah,
98.
so we run to 10, right?
Oh yeah. Okay, so 6.7 or 2.7.
2.7, yes, very good. So in this case, we will have what? Alpha is 35 degree, beta is 130.1 degree. Yes.
Mhm.
And gamma is 14.9 degree. Alpha, A is 6, B is 8, C is 2.7. Yes. So now you will see, right? So these are two different cases, as we can see. Case 1 will be what? The one like this one. The one like this, right? Case 2 is going to be the one like something like this, right? This is alpha, this is beta, this is gamma, this is A, B, C, right? So this alpha, beta, gamma, A, B, C. Yes, so two different situations. Okay. Yeah, let's go through this one, this question. All right. So now in this one, we firstly found this H, right? B equals sine beta. That is 4.5886. Now, since this opposite side 6 is greater than this and less than 8, two possibles, right? Two possibilities, we know that. And then what we want to do is we are going to, by law of sines, we can find we try to find the angle for beta, right? For angle for beta, because B is given. So we can find the possible values of beta. So now sine beta is this one. All right, we can find a beta either equals this one or beta is pi minus this one, because they have the same sine values, right? They have the same sine values. Does that make sense or not? Okay. All right, so either is 49.9 or 130.1. Okay, now anybody know why this one is also possible? In the unit circle, all right. So let me draw this one in the unit circle. Okay, so let me just show why, all right, show why here. This one should be something we have had. Okay. Consider in a unit circle. All right, a unit circle here. So if this is alpha, then take this side, this one will be what? This, not this. This will be also alpha, right? Say that they are symmetric about the y-axis. All right, let me just draw this one again. If this is alpha, we draw another one that's going to be reciprocal about the y-axis. So this point and this point is going to be what? Parallel. This line will be parallel to the y-axis. Yes. Now, since they are parallel with the y-axis, they are horizontal line, right? This one, the height, the y-axis will be exactly the same. The y-axis, y-coordinate will be exactly the same for these 2 points. Yes. Now the y-coordinate will be the sines, right? Will be the sines. Now for this one is the sine alpha. For the other one is what? What is the angle of this one? It equals the sine of what? Pi minus alpha. Yes. Now this is pi, but this one is alpha. So pi minus alpha is this angle. Yes. So that's why sine alpha equals sine pi minus alpha. Good. Now sine alpha equals sine pi alpha because the sine alpha is given as this one. So we know beta equals this one is one of the angle. So another one have the same sign. So that's 180 degree minus this one. This is the other one, right? Two possible angles. And one is less than pi over 2. The other is greater than pi over 2. Or one is less than 90 degree. The other is greater than 90 degrees. Right? Okay.
I have a question.
Go ahead.
When do we use inverse sine?
When you want to find the angles given the value of the track function. For instance, right? This one is sine is given, right? Sine beta is given. So you want to know, you want to solve this triangle. So you got to know the value of beta, right? So now, because the sine is given, we are to find the angle. So you got to use the inverse sine.
So almost always we use, if we want to find the angle, we use sine, inverse sine, right?
Well, but this one is the law of the sines, right? This is the law of sines. So in this case, we can find the sine value, right? So you use the inverse sine, correct? But if you're using the inverse, the law of cosines in the next section, then you would use inverse cosine. Make sense?
Oh, okay, okay. Yeah.
Okay. All right, so this is one of the example we have. All right. Now let's consider another one. Okay. So Zhongxu, can you read it for us, please?
In the triangle shown below, solve the unknown side and angles. Round your answers to the nearest tens.
Okay, very good. Okay, thank you. Okay, how can we solve for this one? Solution, right? Now, I know one angle side, and angle here, right? So it's given here. Solve for the unknown sides and angles. Okay. What shall we do? This is 9, and this is 12. Okay. So it seems like the which is case it is in. I know that this is the angle, and the adjacent side is 9. The opposite side is 12, right? So the adjacent side, well, for this one is the adjacent side is B. The opposite is A, right? So here the opposite, for the opposite is greater than the adjacent, right? The opposite is greater than the adjacent, then there's only one triangle, yes? So the opposite of the angle is 12, adjacent is 9, right? So therefore what?
It'd be a single triangle.
Yeah, since the opposite side of the angle beta, this should be gamma, right? This should be gamma. Of gamma is greater than the adjacent side. The opposite side says C, all right? C is greater than the adjacent side B. There is only one angle, triangle, right? There's only one triangle shown in the figure here, okay? So everything becomes easy for this one, right? So we will have Hans by law. Well, yes, you can find, well, because this is 9, this is 12, you can firstly find beta. Yes, find sine beta at least, right? So by law of sines, we have what? We have 12, well, sine 85 degrees over 12 equals sine of beta over 9. Yes. So you can find the sine beta. Oh gosh, sorry. Okay, so this implies what? Sine of beta equals 9 times sine 85 degrees over 12. So what is that? Anybody find this?
I got 0.7471.
0.7471, right? So therefore beta equals what? Now you want to find sine beta equals this one, so that it's the inverse sine, right? 0.7471. What's the parentheses? So you got this one is in radians, that is 0.8437, right? But you transform it into degrees.
And you got that by inverse the sine of 0.7471. Okay.
Yep.
Can you label A and B as C? It's easier for me.
Okay,
For the graph.
so here's C, here is P, beta, yes. Okay,
Okay.
beta equals sine inverse sine 0.7471 equals 0.8437. But this is in radians, right? But this one can be converted to degrees by dividing by pi and then times 180, right? Like what we did before. So what do you get?
48.3.
48.3 degrees. Do we need to find the other one?
No.
No. All right. So this one is the only one that works. All right, it's the only one that works. We don't have to bother to find the other pi minus this one. All right. You don't have to do that because there's only one triangle. Okay, one triangle. Okay, the other one, if you find it, it will be greater than the summation of 85, and that angle will be greater than 180. Okay, so that's not good. Okay, we will just need this one. All right, we just need this one. So then beta equals this one, and this is the only triangle, right? So beta. Then after we find the beta, then what is the value of alpha?
180 minus
80 minus 85.
Yep.
Yes,
So how's alpha equals 180 degrees minus 85 degrees and minus 48.3, right? Now what do we have?
.7 degrees.
25 or 46? What do you get?
At 46.7.
46.7, yes. 46.7 degrees alpha, right? So that is going to be alpha. Now alpha is known, then can we find A? Using law of sines, right? So again, by law of sines, the law of sines, we have, right, A over sine 46.7 degrees equals, say you can just pick any one, all right? So this one, say like 12 over sine 85. B over sine beta, right? So therefore A equals what? Sine 46.7 degrees times 12 over sine 85 degrees. So we can find this value, right? What did you get?
8.8.
8.8. So therefore we already have everything, right? So we know that alpha is 46.7 degrees. Beta is 85 degrees. Gamma is 48.3.
Beta and gamma are different. They're backwards. Gamma was given, wasn't it?
Oh, yeah. Gamma. Yes. That's right. Gamma equals this, sorry. And then beta equals this, right? Now A equals 8.8. I say C equals C is 12, right? Huh? C is 12, yes. B equals what? 9. B equals 9. Okay, that's good. So we got this, right? So we got everything. We solved this triangle. Okay. Very good. Okay. All right, let's consider another one here. Okay. So Arinda, can you read the first, please? Arinda. Anyway, Nick, can you read the first?
Yes. Find all possible triangles if one side has length 4 opposite an angle of 50 degrees, and a second side has length 10.
Okay, so very good. Solution. Now, firstly, you want to decide which case it is in, right? So you have no triangle, right triangle, 2 triangles, and case of D is going to be just one triangle as well, right? So now let's just consider this one. It is known that one side 4 opposite an angle, right? So this is 50 degree. There is a 50 degree. So this is a 50. Now the opposite side is 4. This opposite side is 4. Well, this is 4, and the second side is 10. So that's going to be 10 is 10 is going to be the adjacent side, right? The opposite side is 4, adjacent side is 10, right? So, well, this might be this adjacent. Okay, let's just do this first without the opposite side. All right, we know that the opposite side is 4, correct? Now, firstly, what is h? Since adjacent side is 10, the degree is 50 degrees, then h equals what? 10 times sine 50 degrees, right? So you want to determine the using adjacent side times the sine of this angle. What did you get?
7.6 or 7.7.
7.7, yes. But this one is not the final answer, right? It's not the final answer. So you can just use as accurate as you want to. So let's just use this one, okay? So that is to say the height. This height h, right, equals 7.6, right? But is that possible for the opposite side to be 4?
No.
No, right? So 4 is somewhere here, right? So that is going to be no, since the adjacent side, the opposite side has a length of 4, which is less than h, right? So it is impossible, right? there's no triangle. No such triangle. So that's going to be the first case, case A. There's no such triangle, right? Make sense? You don't
So
have to.
H,
Mhm.
to find H, we always use the angle that's opposite of H.
You
And-
always use an adjacent side, right? Adjacent side
Adjacent
times,
side to H,
yeah, times the sign.
the angle.
Yeah.
Okay, okay.
So
So if the adjacent side was on under the bottom of 50, you use the same thing?
yeah, it's the same thing. These two
Okay.
sides. As long as it's an adjacent side, you can find the H, right? Because that's the adjacent side, the opposite side, right? And the angle. Very good question, right? So since H equals this one, the opposite side is length of 4, which is less than H, then there's no such triangle. You don't have to use to do any more work because there's no such case.
Okay.
Okay. Now let's move on to this one, all right? So finding the area of an oblique triangle. So anybody remember the how to find the area of a triangle, of an oblique triangle? It is a base,
Times
one
height,
half, one half,
yeah.
yeah, one half base times height, right? One half base times height. That is the area, okay? But what is H, right? What is H? Now H, it seems like you can write this, for instance, this is alpha, right? And this is C. Now sine of alpha is what? H over C, yes? So it seems like this one implies that H equals what? C times sine of alpha, correct?
Mhm.
Then area equals 1/2 B times H, by substitution is 1/2 B times C times sine alpha, because C times sine alpha is H, right? So it equals what? 1/2 BC sine alpha, correct? Okay. Now the same thing is for this triangle as well. If it is the alpha is greater than 90 degrees, now sine alpha and sine alpha prime is going to be the same. And then you also have this one, okay? So you also have this one. So it is going to be 1/2 BC times sine alpha. Now you see that alpha is the angle between the sides B and C. Yes? So it is 1/2 times two adjacent sides B and C times the angle, sine of the angle between them, right? Okay, 1/2 times product of two sides times the sine of the angle between them, right? Okay, so either way will be fine, all right? So that's the formula of the area. Area equals 1/2 BC times sine alpha, AC times sine beta, and AB sine gamma. All right, so alpha, beta, gamma, A, B, and C. All right, so it's the 1/2 times the product of two sides, right? And then times what?
Times the sine of the angle.
Sine, yeah, the sine of the angle between them. The two sides. Right? So 1/2 times the product of two sides times the sine of the angle between them. Okay, so that's what we mean by this. Either two sides will be fine. Either angle will be fine, right? As long as the angle is between the two sides, you choose. Okay. All right, consider this example. Mustafa, can you read for us, please?
Find the area of a triangle with sides A equals 90, B equals 52, and angle gamma is 102 degrees. Round the area to the nearest integer.
Right, this is the gamma 102, right? Size A, and this is B, and this is C, right? So this will be alpha, and this is beta. Okay, so here A and B are given, gamma is given. So is gamma in between A and B?
Yes.
Yes. So the area is what? 1/2 AB sine of gamma equals 1/2 times 90 times 52 times the sine of 102 degrees. So equals what? 25 times 90 times 52 times sine of 102 degrees. Anybody got this? Nearest integer.
I got 2,288.
89.
89. Sorry.
89. Round to nearest integer, right? 89. Okay, that's it. Very good, right? So you see how we can use this one to find the area of a triangle, right? Given two sides and the angle between the two sides. Okay, consider another one. Nick.
Yes. Find the altitude of the aircraft in the problem introduced at the beginning of this section, shown in figure 16. Round the altitude to the nearest tenth of a mile.
Okay, sorry. It should be something like this. All right, let me just show you. Let me just draw this thing. All right, here it is. I believe this is 15 degrees, and this is 35 degrees, and this length is 20 miles. All right, so this is radio station A. This is not the radio station, and then this is the aircraft. This is the aircraft, a plane, right? So you want to find the height, h. Want to find the height h. And we found this one. Basically, it's solving the triangle, right? Well, you definitely can solve the triangle. Find say this side and this side times sine 15. That's going to be h, right? Okay, so do we have enough time here? Okay, well, I do not think we have. Okay, say that this is alpha, this is beta, this is gamma, 20 miles, right? So this is C, this is B, this is A. If this is 15, this is 35, then what is gamma?
140? 130?
Yeah, so 130. So by law of sine, right? So C 20 over sine 130 degrees equals what? b over sine 35. Okay, so you can find a b, right? You don't have to do that. So this means b equals, right, sine 35 degrees times 20 over sine 130 degrees, right? So you can find a b. After you find a b, h equals what? B times sine 15 degrees, right? So you can find this, correct? All right, I think that's already time. All right, that's already time. But you can find, I believe this, you can find this, right? So the idea is firstly find a b, and then the height is going to be just a b times sine 15, right? So you can also find a. Now h is going to be a times sine 35, right? So
Can you do c sine 15? Would be the same thing, 20 sine 15, because it's adjacent to.
oh no,
Or
no,
no?
no, no, no. You are
You
trying
can't.
to find the height, the altitude of the aircraft,
Okay.
right? That is the h, right?
So if c passes h, then we cannot use it. But if it doesn't, then we can. How does it work?
Well, you see, you got to use the right triangle relations, right? So because now here B is the aircraft is flying on the top, and this one is the altitude is based on our notation here. You can clearly see that h, right, sine of 15 equals what? H, the opposite side over B. Yes? You never have, okay, so this is a triangle, correct? This is a right triangle. So sine 15 is h over b. It's not h over c, right? So you got to use the notation. We have this notation. You have to based on this notation and using the right triangle of these relations, right? Sine 15 is h over b, then h equals b times sine 15. Right? You always based on the right triangles, the geometry, correct? Now this is different from Mustafa. It's different from this one. What I know what you mean when we talked about this one, right? Find all possible triangles, right? So this one, a second side is 10. So I said either one is fine, right? Because the second side is an adjacent side. Now, this is a different story about that problem because here we are trying to find all possible triangles. You can use either side to decide h, right? Now you can see, right? So we didn't specify which is which, right? This one is just to figure below, right? With the known size a, b, and known angle alpha, right? Here, a is the opposite. B is just one of the adjacent side, right? I didn't say it is a bottom one or it's a top one, right? It's just a one, right? It's just a one. Now, however, in the example we did here, it is a real life problem, right? C is on the ground, correct? And this is a totally different story. Now, for this one, for the one we said, you got to find all possible triangles, right? It's not a real life problem. You got to figure out that. So that in that one, we have these 4 different situations, all right? So the adjacent side can be any adjacent side, okay? Because you want to find all possible, you want to solve the triangles, right? Now, however, the one we say here is a real life problem, and you got to use geometry, right? The right triangle to find h. Okay, anyway, this is already time. I hope that helps. But all right, so okay, I definitely will make sure that there will be homework for both sections. All right, sorry about that. And
All right.
there will be a